Okay, so let's review the just combining like terms. Very basic, but it's necessary. What is 5x plus 3x? No trick question here. What is it? 8x. Okay, very important to know. What is 5 plus 3? Right, not a trick question. What is it? 8. Okay. Most importantly, though, what is 5x plus 3? 5x plus 3, right? Those cannot be combined. So the purpose of this is what can be combined. You know, same variable, yes. Just numbers, yes. But if one's a number, one's a variable, no. Okay, it cannot. So that's important when we're adding to both sides. And well, you can't add 3 to negative 3 and add it to 5x on the other side. You have to add numbers with numbers, variables with variables. Okay. All right. So we've done this already. Isolate the variable, get that variable on one side of the equation, and it doesn't matter which leads to different ways of doing the same problem. And we've always undone the operations with their opposite operations. So if it was plus 5, we subtracted 5. If it was 7x times 7x equals 14, that'd be multiplication, and we divide. We always do the inverse. Okay. Just whatever you need, take notes. Right, so this is what we've been doing, and then of course it's easier to add, subtract before you multiply, divide. But that's not always the case, but sometimes. Most of the time, we add, subtract, then multiply, divide. And we saw some instances where we did not. Okay. Alright, so what happens today when you have variables on both sides? Okay, got variables on both sides. Something like this. So I think we had some mixed ones in there like this, but we haven't done a whole day of just practicing this. Okay? And basically follow the same rules, it's just we have to do one more step than we've done before. You can do this multiple ways. So, like for instance, I need to have x equals at the end. So I can't have an x over here and x over here. And we know from the warm-up, well, I can subtract them and combine them together. Right? Now I only have a single variable, and I can solve that. And so it's very similar to when you have a number on either side, we combine them into a single number. Okay. Now from here, since we put the variables on the right-hand side by subtracting it here, we need to get the numbers to the left-hand side. So once again, the opposite operation, right? So we got 7 equals 3 times what? 3x, right? And you can divide by 3 or multiply by a third on both sides, just like we have been doing, and get your final answer, 7/3. I mentioned earlier that we haven't had a lot of fraction answers and things like that. That will change coming up. We'll get more into that. So if you get fraction answers, don't say I must have done something wrong because it's a fraction. It's perfectly fine. And please leave it like that. Don't change it to like 2 1/3 or anything. Just improper or proper fraction works fine. Okay. Now, you know how you guys always begin the period, check each other's work. One thing that will happen tomorrow is that every problem has many different directions to solve. So go ahead and write this kind of towards the middle of the paper, and an arrow going down to the left. And I'm going to do another arrow going down to the right. I'm going to do the same problem twice, so you can see that, yeah, there's 2 ways and sometimes more than 2 ways of doing these. And you get the same answer. That's just so when you guys are checking each other's work, you don't say, well, yours is wrong because you did this and I did this differently. If you do it differently but you come out with the same solution, it's perfectly fine. So you just got to be aware of that. And the further you go in math, the more this happens. I know a lot of you probably have been told math is just the one way and this is how you do it, but the higher you go, the further you go, there are going to be many ways. And you can really learn them all and use the one that you like the most, and that's perfectly fine. Alright, so we need to get the variables by itself, which means I can get rid of this 2x by subtracting 2x, or I can get rid of the 5x by subtracting 5x. And those are the first steps of the both methods. Okay? So I'm going to start off on the left-hand side just by subtracting the 2x. Okay? So most of the work is bringing down what you didn't use. We just bring down the 4, the equals, the minus 17, and just simplify that 5x minus 2x just like we did in the review, right? Next step is, maybe get rid of the negative 17, add 17 both sides. So we got 21 equals 3 times what? And we can multiply by the reciprocal on both sides, and we'll get our answer of 7. Now, the other way says, oh, by the way, you can divide by 3 instead of multiplying by a third. The other way says, well, why don't we start off by subtracting 5x instead? It's still just as valid. It's still doing the opposite. That's perfectly fine, right? So we'll get negative 3x plus 4 equals negative 17. A lot of the same numbers. If you look across, like we had a 3, we had a 17, we had a 4, now we have some that are negative instead of positive and vice versa, so it's similar. It's not the same, but it is similar. We can subtract 4 on both sides, get that numbers over there. Okay. So here we got 21 equals 3x. Over here we have negative 3x equals negative 21. So very similar, right? And then when you do the last step, the negatives, negative 21 over negative 3 cancels out, and you do get positive 7. So there's two approaches. On the left-hand side, the person that does this likes to stay away from negatives. They recognize from the beginning, well, I'd rather do 5 minus 2 because I'll get a positive 3x, and I tend to mess up on negatives and things. So if I complete this problem in a way where there are no negatives, probably be fewer mistakes. Okay, so that's one approach. Just avoid negatives. That's the left side. The right-hand side says, you know what? At the end, I like having the variable on the left and the number on the right. So no matter what, I'm always going to, if it's negative, positive, doesn't matter. I'm always going to move the variables to the left and always the numbers to the right because I just kind of like that format. It's consistent. Every problem's the same. Whereas the left-hand side, sometimes the variable will be on the right, sometimes the variable's on the left. You get the same answer no matter what. So you just have to, play with it and see what type of person you are. Alright, so 2 methods on all of them. Okay? And maybe more when we start adding parentheses and the combining like terms like we did last night. We'll add all that in too. Alright. So go ahead and jot that down. Let's review what we did yesterday and combine it with this as well. So notice how that left-hand side has a lot of stuff. So the number one mistake when we start doing really big problems is that we want to start solving really fast. We want to start adding, subtracting to both sides and things like that first. But as we saw yesterday, you want to simplify your life. So you could subtract 3x on both sides and then add 2x on both sides and then, do a lot of adding, subtracting on both sides over and over and over, but it might be easier just to recognize this. They're on the same side. 3x minus 2x, that's 1x. 6 and a plus 4, that's 10. Do this first. Combine all the terms on the same side. You notice how I didn't add 2x. I didn't say plus 2x and get 5x here because they're on the same side. Same thing here. I didn't go, okay, right underneath minus 4 and minus 4 and get a 2 because they're on the same side. And now, at this point, this is where you want to start solving. Add and subtract to both sides. So very key, important step not to forget. And again, at this point, you could do a different way. You could subtract x on both sides if you wanted to. Completely up to you. Finish it up. Multiply by reciprocal or divide by 5. And this part, I'm going a little faster because it's more routine. It seems that once we get to here, when there's only 2 steps left of subtracting and dividing, it's done very accurately most of the time. It's at the beginning that we want to be careful. Don't start adding, subtracting on both sides. Combine terms first. And if you like what I did with colors, or you can use highlighters, or you can underline a certain way, whatever works for you. Keep organized. Alright, if anything else, work on this organization. You see how all the terms are spread out? There's plenty of room. Equal signs, you see how they line up perfectly all the way down? It keeps everything really organized. Not to mention just the penmanship itself will help you avoid mistakes. Alright, good. Let's just have you practice this one. Check with a neighbor, see how it goes. I'll walk around, see how everybody's going too, just to make sure we got this. Once again, let's go over this. 10 and 56 on the same side. First thing you want to do, put those together. Very important. Make your life easier. Otherwise, you have to subtract 10 on both sides, and then you have to subtract 56 on both sides. Twice as much work. Might as well put them together and subtract one time. And or add. Okay? So here I decided just to go with, I want to keep, the variable positive. So I have a choice. I can do 5 minus 12, get a negative, or 12 minus 5 and keep it positive 7. So I'm going to go that route. And I just drop down everything else. Don't forget to bring down the minus sign. That counts as a negative, right? And keeping everything lined up as possible. So I'm going to move that 66 to the other side. Negative 96. And then multiply by the 7th. So negative 96 over 7. Just watch that negative, because that's, if there was a mistake, it was probably the negative, right? You miss one little thing. So be very careful on that negative. Write bigger, write neater, and that will happen less frequently. One thing, if you want to try this, and this occurred to me probably halfway through my senior year with taking math, is that I started doing homework on blank paper. Because writing on all the lines were too skinny, too small, and I tried to fill in between the blue lines on a piece of paper. It was too small for me. When I just did it on blank paper, I just wrote bigger and it was easier for me to read, and I didn't make as much mistakes. Kind of like on the tests and the quizzes. It's blank, and you tend to write bigger and write clearer just because you're not trying to be constrained between all those small lines. So give that a try. See if it works for you. Sometimes just writing on blank paper makes a huge difference. Not having all those blue lines go through your paper, all your work. All right, good. All right, let's review 3 different types of answers. Can you name what they are? I just said, open-ended question. What are the 3 types of answers? If not, time to write down. Make sure we know this. All right, so first type is the most common. Okay. We start solving. What goes on the right-hand side at this point? What's 12 minus 12? 0. Yeah, if there's nothing left on the right-hand side or a left-hand side, it's a 0. So this has an answer. It's 0. Right? Variable did not cancel out. We just got x equals 0. So that's probably the most common when you have one solution. You get an answer, basically. That's most of the equations. Pretty much everything you've been doing has an answer. Okay? There are 2 other special cases. How do you know if you have one of those special cases? What gives it away? Okay. Another good question to ask yourself. Okay. So let's start off by, once again, we have variables on the same side. Make it a 3x. Don't subtract 2x on both sides or anything like that. Just combine them together. Now, here's how you know it's a special case. You have the same variable on both sides. So when you go to solve and subtract them on both sides, yeah, there's no more variables. That's a special case, when you don't have a variable left over. Okay? So if you have no variable left over, it's one of 2 things. It's either an all real solution or it's a no solution. Okay? This one is an all real. The way you know that is what you're left with is actually a true statement. This is saying 8 is equal to 8. That's true. Okay? That's true. So you say any real number. Okay? Any real number, or all real numbers is another way of saying that. Okay? As opposed to this, if you solve this, what's left over is false. And that's how you have a no solution. That's a no solution. Those are your three types of answers. One solution, which is most of the time, and then there's two special cases, all solutions, all reals, true, or no solutions when the last statement is false. The thing they have in common here, B and C, is that the variables cancel out to 0. Up here, the numbers cancel out to 0. The answer is 0. That's not the same as the variables canceling out here, 3x minus 3x, and having no variable at all. Okay. Very good. Let's just do this mentally. What do you think? Will this be a one solution, no solution, or all reals? Yeah, so you can see how we have the same variable on both sides, so the variables will cancel out, right? So it's going to be a special case, so that means it's either an all real or no solution. Look at what's left over. Is what's left over going to be true or false? Yeah, -8 is not equal to -86. It's a no solution. And then we can show the work to prove that. Yeah, -8 is not equal to -86. No solution. Yeah. And then here, you can see again, same variable on both sides. So when you add it, it'll both cancel out. What's left over? 4 is equal to 4, which is true. Therefore, all reals. If there are many solutions, any real number, lots of ways of saying that. Okay. All right. You won't see this today, but then review tomorrow for your quiz on Friday. It will have it. So we'll talk about this a lot tomorrow and do some practice with it. Okay. Let me pass out the homework and show you one more thing, and then we can get going. Last thing I want to do is just show you some shorthand. If you like, you don't have to do this way, but if you like this is the same question. So I have a choice here. Remember, I can either say I always want the variables to be on the left, or I can try to avoid negatives. So first, let me just try to avoid negatives here. Simplify all this. That cancels out. Bring everything straight down. Keeping things nice and organized, lined up, equal signs. Whenever you don't use, it should be right below. Okay? If like this, let's see, 0.2, bring straight down. And then 20 minus 14, we'll have positive 6. Okay. Then we want to get the numbers to the other side, so let's subtract 22 on both sides. Okay. Notice how I'm going to drop the 6p straight down, keeping things organized. So all the way down right here, I can see all the variables. Very easy to follow. Even if there's a space right here, keep equal signs lined up. It's okay if there's a space here where it's canceled out. And now we'll have -30. And lastly, 6 times what is -30? So we can see that answer coming. We can divide by 6 or multiply by 1/6. -30 divided by positive 6 is -5. And even though there's a big space here, it keeps everything nice and well organized. Alright. Now, a lot of people like this method where you do one step at a time. But I'm going to offer a chance to combine both of these steps right here. Do both steps at the same time. And some people like it because, well, it just does it faster, number one. And number two, it helps avoid mistakes. So let me show you another method. If you like, you can do this. This applies when you have variables and numbers on both sides. So there's usually a variable number on the left side and on the right side. You can do the same, both of those steps at the same time. So you can do this. Subtract 14p on both sides, just like we did before, right? But also, subtract 22 on both sides. Right? So everything has something written below it. Everything is being added, subtracted at the same time. And since variables and numbers don't interact with each other, you never add variables and numbers together, you can combine them. So we can say from the left to right, okay, that cancels out equals 0. This equals negative 30. Bring down the equals sign. That equals negative 22. And that equals 16. Done a lot quicker, right? So if you like this, you can use that as well to solve. Okay? Alright. And there's the final. Okay. Tomorrow we start reviewing for the test.